the factor theorem? The factor theorem states that if you have a polynomial function, it's going to have the factor x minus k if and only if the function value at k equals 0. So, if k is a 0, then x minus k is a factor. So if we look at this graph, we can see 3 x-intercepts of this graph. So these x-intercepts occur when x is -2, when x is 1, and when x is 3. So that means this polynomial has a factor of x minus a -2, which is x plus 2. It has a factor of x minus 1, and it has a factor of x minus 3. Write the complete factored form of a polynomial function that has zeros of -2, 4, and 0, and 8. And we know that polynomial has a leading coefficient of 1. Well, if x equal -2 is a 0, then we know x plus 2 is a factor. If x equal 4 is a 0, then x minus 4 is a factor. If x equals 8 is a 0, then we know x minus 8 is a factor. If x equals 0 is one of our zeros, that means x is a factor. So since it's just plain old x minus 0, I'm going to write it first. And the leading coefficient is 1. So I could put that 1 there if I wanted to, or I could just leave it off. X times x plus 2 times x minus 4 times x minus 8. This would be the factored form of my polynomial function. Now here I'm asked to do the same thing, write the complete factored form, but I have to read my information from the graph. Assume my leading coefficient is either +1 or -1. And assume our graph is on a standard window. Well, I can see 3 x-intercepts. So I know that this graph is going to have zeros at x equal, let's see, if this is my y-axis, this would be at x equal -2, at x equals 0, and at x equal 1, 2, 3, 4, 5, 6. So I know I'm going to have factors of x plus 2, x minus 6, and x. The leading coefficient is going to be either a +1 or a -1. So we've got to use what we know about polynomial functions to determine that. Since this has 3 x-intercepts, I can assume this is a 3rd degree polynomial. I only have 2 turning points, this one here, and this one that's going to occur way down here somewhere where I can't really see it. So since this first tail is going down, when my x's are negative, my y's are also negative. That means my leading coefficient is a +1. If the x's were negative and the y's were positive, my leading coefficient would be a -1. So this would be the factored form of the polynomial in this graph. Now this time I don't know the value of a. I know my zeros are -4, -6, and 3. So that means my factors are going to be x plus 4 times x plus 6 times x minus 3. But all I know here is that if x is 0, my y value is 10. So my polynomial is going to look like this. The only thing I don't know is this value of my leading coefficient, which is my a. I do know that f of 0 is 10. So let me plug in the 0 for x. That would give me a times 0 plus 4 would be 4. 0 plus 6 would be 6. And 0 minus 3 would be -3. When I plug 0 in for x, this should equal 10. So let's see. I'll multiply these together. This would be 24 times a -3 would be a -72a equals 10. So I can solve this for a by dividing by -72. And I get that my leading coefficient is -10 over 72. I can reduce that to -5 over 36. So my polynomial now is -5 over 36 times a plus 4 times x plus 4 times x plus 6 times x minus 3.